Assalamu alaikum. In this video, we're going to split up white light into its spectrum of colors. In other words, we're going to split up or spread out white light into the 7 basic ingredients, the 7 basic colors that make up that white light. You see, white light isn't really a single ray of light. In fact, it is 7 different frequencies or 7 different colors of light. Red, orange, yellow, green, blue, indigo and violet that are superimposed or stacked one on top of the other to create that white light. So in order to carry out this experiment, you require a source of white light. You could use the sun's rays, that would be ideal. In our case, we're going to stick with a ray box as our source of light. We're going to use a power supply to power up the ray box, and of course the triangular prisms that are going to spread out or disperse the white light into its spectrum of colors. Now, the way it works is this: as the rays of white light come from the ray box and approach the triangular glass prism, of course they're going to refract. So they're going to refract because there's a change in optical densities. The ray of light is going from a less optically dense to a more optically dense medium. But here's the catch. Not all of those 7 rays of light, or 7 frequencies of light more correctly, are going to refract by the same amount. In fact, each frequency of light, each color of light, refracts by a different amount according to their own refractive indices. So for example, red light has a much smaller value of its refractive index, and therefore it refracts much lesser than violet, which is at the other extreme of the light spectrum. So violet, on the other extreme, has a much higher value of the refractive index, and therefore it refracts much more than red light. And so the rays of light start to spread out into their respective colors according to their own frequencies and hence according to their own refractive indices. Well, you might be inclined to think, hang on, why did this happen? Why did white light split up or disperse when we conducted the experiment using a rectangular glass block? Well, the fact of the matter is, white light did disperse into its 7 colors according to their own refractive indices. However, as the white light emerged at the other end, so all of those colors refracted back by the same amount. Therefore, all of those 7 colors superimposed on top of each other once more as they exited the glass block. And that's why you saw a white ray of light entering the glass block, and that's why you see the same white ray of light exiting the glass block again. But this time, because we're using a different geometrical shape, those different frequencies of light, those different colors of light don't get to superimpose on top of each other once more as they exit that triangular prism. And that is why they keep spreading further as they exit the triangular prism. Now, when I turn on this power supply, so when I turn on the ray box, you can see the ray of light entering the glass prism and refracting by a certain amount. And in my experiment, in my case, you don't have to do the same. This works with a single prism as well. But in my case, I've used 2 prisms in order to further refract or spread out those different colors. And you can see behind me, over here, how the different colors are now spread out into red, orange, yellow, green, blue, indigo and violet. So in this case, you can see that white light has spread out into red, orange, yellow, green, blue, indigo and violet. So red refracted the least because it had a much smaller value of refractive index, and the value of refractive index and hence the refraction increases as you go down the spectrum through orange, yellow, green, blue, indigo and all the way through to violet. And that's that. Thanks for watching.